So continuing with this issue of the square and square root not quite being perfect opposites, we can compare the answer to square root 25, which is 5. Okay, so the square root of 25 is always going to be the principal square root, which is positive 5. And we're going to compare that to a solution of x squared equals 25 when we solve this. So again, we use an opposite to solve. We square root. And if we just did the principal square root, we get x is equal to 5. Now this is a problem because if we look at the original equation in black, well, 5 squared definitely equals to 25, but there is another number squared that will equal positive 25, and that answer is negative 5. And so when we undo the square with the square root, because they are not perfect opposites, we lose an answer. So whenever we have an even power like this, we always have to do a plus minus. Because not only the principal square root is a solution, but the negative square root is also the solution to an x squared problem. So these are two different ways that issue of the x squared and square root are not perfect opposites of each other. Okay, if we square and square root, we actually don't get exactly what we started with. When we solve, okay, again, solving involves using an opposite. When we solve, because the square and square root are not quite perfect opposites, we always have to remember to do the plus minus when we solve an x squared equation. Okay, and this is what we call a quadratic equation, and quadratic equations always have two solutions. So you need to come up with a way you can help yourself remember this, because this is something that in grade 10 a lot of students make an error with and not quite wrap their head around. Okay, so you need to come up with some kind of system yourself. Now I can kind of help you and guide you with this, but you need to have some criteria for yourselves. So one way that I always kind of think of this is that an x squared is a quadratic. That's what we call a quadratic because it makes a four-sided square. Okay, and quadratics we always have to consider two answers. Okay, and this is in equations, and maybe we should qualify this. This is for equations only, when we're solving for x, not when we're just rearranging expressions. So there's two solutions, and we always have to remember the plus minus because of the two solutions. And what we can generalize about odd powers and roots versus even powers and roots is that if we have an odd power equaling a negative, that's okay. No big deal because we can undo negatives. Okay, when we cube root, I'll do this in a different color. When I undo the cube with a cube root, all the odd powers, the cube and cube roots, the fifth power 5 and fifth root, etc., they are perfect opposites. And we end up with x equals to negative 2, not plus minus, because we don't worry about plus minus with odds, because we know that x equals negative 2 cubed is going to give us negative 8. Positive 2 cubed is not going to give us the negative there. Okay? Whereas if we have an even power, even powers, x squared equals 4. Well, positive 2 squared equals 4. Negative 2 squared equals 4. So when we square root this is when we have to make sure we use that plus minus. Okay, because the even powers are not perfect opposites of each other. And we're going to generate this plus minus issue when we solve for x. Okay, so positive 2 squared equals 4, negative 2 squared equals 4. We end up with plus minus. So the even powers, which I'm going to highlight here, even powers Okay, we always end up, must remember, plus minus.